if we are talking about the recursion, there is a famous problem, this sorting algorithm, that is merge sort. We are going to discuss the merge sort now. So I hope you have already heard about that. Let's quickly discuss what a merge sort is. Then we'll prove that problem. Okay. So let's say there's some numbers are given. Let's say, okay, I'm not going to draw it. I'm going to type it. Let's say some numbers are given here, and let's say 17, comma 25, comma 16, comma 8, 7, comma 9, comma 48, comma 49, comma 2. Let's make a space here, comma 2, comma, let's say 42. Okay. So what we are going to do into the merge sort, why we are discussing the merge sort in the recursion, because let's first discuss what a merge sort is, then we'll discuss why we are doing it with the help of recursion. Okay. So what merge sort says that that divide this problem into the sub problem into, let's say if you have given with this array, divide this array into two sub arrays and perform the merge sort again. So what it means, let's say what is the size of this array? That is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's say 9 elements are there. Let's say 5 comes to this side and 4 comes to that side. So we have divided our array and 5 elements are this side now, 5 elements are this side now. So what I'm going to do now, again, I'm going to divide this array again into two sub arrays. Let's say this time it will be 17, 25. Let's say 17, 25, 16. And the other part is, let's say 7 and 9. Okay. And this, in the same manner, I'm going to divide my this arrays in the same sub arrays, 48, 49 to 42. Okay. Again, what we are going to do, we are going to divide our array, this array, because this is again an array. We are going to divide it into sub arrays. Let's say 17, comma 25, comma 16 again, comma, and we are going to write 7, 7 and 9. We are going to divide 7 and 9 because 7 and 9, two elements are there. And in the same manner, I'm going to divide 49, 48 and 49, and 2 and 42. Okay. We have already divided these elements. It means they are now in the single elements. These two are in the same array. Let's say, let's divide that also. 17, 25, 16, 7, 9, 48, 48, 49, 2, 42. Okay. So by dividing it half by half, we have come to a position that in all the sub arrays there is only one element, and we all know that if there is only one element into an array or into any data structure, that is already sorted. So now what I'm going to do, so if these two if 17 is already sorted, in which manner we have divided it, we are going to merge it again. And let's say 17 and 25, if separately they are already sorted, so I'm going to merge them because we have divided 17 and 25, then with 16 I'm going to merge it with the 16. Okay. So what I'm going to do, 17 is greater than 25. No, 17 is smaller than 25. So 17 will come first and 25 will come later. Again 16 is here because there is only one element in that array, so I'm not going to do anything. Again for 7 and 9, we are going to merge it again because we have divided it into two separate arrays. So for 7 and 9, what I'm going to do, which elements comes first, I'm going to write that first. So 7 comes first and 9 comes after that. Let's say 7 and 9. Again, in the same manner, what I'm going to do, we have divided 48 and 49 into two separate forms. So I'm going to write 48 and 49 because 48 comes before 49. So we have divided 2 and 42 because 2 is smaller than 42. So I'm going to write 2 and 42 together. Okay. So after this merging, so we have what we have divided 17, 25 and 16. So I'm going to merge it with this again. Okay. So these two are the already sorted arrays, means these are the already sorted. Okay, these are the sorted arrays. I'm going to merge in the same manner again. So 17 and 25 is there. So the 16 will come before 79 because 16 is lesser than 79. And in that second array there is nothing now. So I'm going to write the first array as it is. 16, 17, 25 and 7 and 9 is still the same. They are 48 and 49. Let's say 2 and 42. Okay. And what we are going to do now, because we have already sorted this array, we have already sorted this as well. So I'm going to merge them again because they were the arrays that was being divided. Okay. So 16, 17. Okay, no, sorry. The 7 will come first, and then 9 will come, then 16, then 17, then 25. How we are merging them? First, we are comparing the first and first elements. Let's say 16 is less than 16 is less. Sorry, 7 is less than 16. So I'm writing 7 first. Then 9 comes. 9 is less than 16. So I'm writing 9 after that. And after that, there is no array in the second. There is no element in the second array. So I'm writing the element of the first array: 16, 17, and 25. I'm going to merge them in the same manner. So 2 is going to come first, then 42, then 48, then 49. In the same manner in which we have divided, we came to in that form again. So we have reached to the same condition again, in which form we have divided. But this time, this is in sorted array, and this is also in sorted array. So again, we are going to merge it in the same manner. Uh, that is 2. Let's say after 2, first we are going to compare 2 and 7. 2 is less, so I'm going to write 2 first, then 7 with 42. Now 7 is less, so I'm going to write 7. Now 9 with the 42. Now 9 is smaller. Then again 16 with 42. Now 16 is smaller. 17 with 42. 17 is smaller. 25 with the 42. 25 is smaller. Then 42, because all the elements that are left in the secondary, I'm going to write it as it is. So we have got our array in the sorted form using merge sort. Okay. Is the concept is clear? The merge sort concept, or do anybody is having any doubt? What we are going to do, we are going to divide our array. Let's say if elements are given in the array, so we are going to divide that array into two sub arrays, and for the same for the sub arrays again follow the same criteria, that divide that sub array into the two equal sub arrays again. Okay. And if we get only one element, we all know that one element is already sorted. Again from bottom we are going to merge them again. Okay. Is it clear, or do anybody is having any doubt in the merge sort? If you're not having any doubt, we can move to the coding part. Sam, okay, Shrey saying it is clear. Good. So, okay, let's come to this again. So I have discussed that merge sort, but what we have did, why we are doing it using recursion, because we can see that if we have given with an array, we are dividing it into two arrays. Again, that sub arrays is going to be divided into two sub arrays again. Again, for this, it means we are doing the same task again for the sub problems. Means if it means that we are able to divide our main problem, that is a big problem, into the two smaller sub problems. Okay. So what I'm going to do, I'm going to code it first. Let's say I have given with an array. Let's say int of array. Let's say elements are what the element was 17, 25, 16. I'm going to write the same elements. 17, I think it was 17, okay. 17, 25, 16. Okay, I can copy it. So these will be the elements. Okay. So let's create a size variable that is going to take care of the size of our array. How we are going to calculate the size of ARR divided by size of any element in the array. Let's say ARR of I. It is going to tell the number of elements in our array. Okay. Then what we are going to do, we are going to create a function. Let's say we are going to first create a print function, print of array. If I'm passing my array and as well as the size, what it function should do, it should just print the data of my array. Let's say void print the array. Let's say void print int array comma int size. Okay, just wait. Yes, what we are going to write in here, that printing elements of the array. See, I'm writing a for loop here. Int I is equal to 0, I is less than that size, and I plus. It's not going to do anything. We have not declared I. Okay, sorry. It should be. We can write 0 here. Thank you, Shin. It is. It can be any element. So I've written the first element, the size of the complete array, and divided by the size of one element. Okay. So see out array of I space. Okay. Let's change the line here. Let's see whether our print function is working on it. It should just print the array. Okay, it is printing the elements of the array. And now we are going to create a function. Let's name it merge or merge sort, because we are going to create a merge function, another merge function. So what merge sort is doing, if I'm passing my array and the starting position as well as the end position, because we are going to call, let's say the end index will be size minus 1. I'm saying that in this case you have to start from 0 and you have to go from size minus 1. It means this is the limit. This is in this manner you have to sort the array. Okay, let's say void merge sort. And what I'm doing with the merge sort, I'm saying that calculate the middle element. Let's say m is equal to, okay, I have to declare it here as well, array. Let's say array is being passed. Let's say the index is left, comma int right. Okay, either you can write lr, you can write anything. So we are going to check which one is the middle index, because we are going to, in the from starting to that middle index, we are going to call that merge sort function again, and from middle plus 1 to end index we are going to call that merge sort function again. It means we are dividing our merge sort, we are dividing our array into two forms. Okay, left and right. Let's see, left and right divided by 2. Either you can write that right plus left. I think it is right plus left minus something. Yes, you can write that as well. Okay, so what I'm doing here, I'm calling my merge sort function again, and I'm saying pass that array same, but this time your limit is from left, you can go to middle, that is m, and again I'm calling my merge sort function, and I'm saying your limit is now m plus 1 to right? Okay. And okay, so what this will do, this will keep on dividing my array. And once if I've divided my array, if I reach, let's say if I reaches to one element, so what I'm going to write it here, I'm going to set in base case if my left is less than right, then do this or do not do nothing. Or we can write if left is greater than or equal to right. It means if the left and right is the same, if we are in the same, let's say left and right is the same, it means there is only one element. So what you need to do, or left becomes greater than right, it means left goes to right side and right goes to left side. It means that now we cannot divide our array. Either you can write this, either we can write if left is less than right. In that case, you have performed these operations, otherwise do not do anything. Okay. So either we can write that base case, either we can write this. This will be the base case for this merge sort. Okay. And I'm saying if you have divided our array, if you have divided means it will, what it will do, it will keep on calling my merge sort function again, and it is going to. So if we have already divided our array, and what we are going to do, we are going to merge them now. Okay. For merging them, what I'm going to write it here. Let's say if I'm passing my array, I have to pass that where you have to merge. You have to, let's say if I'm passing my array and I have to pass that my from left to right. You can go from left to right, and from where we have divided our array, let's say I'm telling that merge function that we have divided, your limit is from left to right, that from left to right you have to merge, and we have divided this from the index at the index m. Okay. So what I'm going to do here, I'm going to create a merge function. This will take the array as well as int left as well as int right and mid. Let's say mid or m is fine. So uh, let's say, let me open my pen. Let's say you are given with an array, and now limit is from, let's say this time limit is from left to r. Let's say r is here. Okay. Sorry. Let's say limit is from L to R. Let's say you have to, your limit is left, that is left, that it is right, and mid will be here. Okay. We have already passed our mid. There is no need of calculating mid again here. So what I'm going to write, I'm going to create an array of this size, and I'm going to create an array of this size. Okay. I'm going to fill that array with the values that is there into this array. Okay. It means we are copying that value of that array. And now what I'm going to do, I'm going to compare the elements one by one. Which elements we have to write, I'm going to update it into the main array again, and I'm going to return it. Okay. So so what I'm going to do, int, I'm going to just get what should be the size of my these two arrays. Let's say, so how I can know the size of that arrays. If we know that let's say int size 1 is equal to, what it will be, let's say it is starting from, if it is starting from L and it is going to M, so it will be M minus L. Let's say L is 0 and M is 5, so 5 minus 0, it should be the size of 5. It is starting from, if it is starting from 0 and it is going to up to 5, so it should be yes, it should be the size should be 5. Okay. M minus L, no, it should be 1 greater than. Why? Because let's say if it is 0 and if it is 5, if we're starting from index 0 and if we are going to up to index 5, so the size should be 6, because if we are going to from 0 to 5, you have to make the size of that array should be 6. Okay. And let's say int size2 is equal to r minus, so if I want to know the size of this array, what I'm going to write, r minus m. Let's say this is 5 and this is 10, so 10 minus 5, what we are going to write, let's say r minus 5, because we know sorry, r minus m, because we know that if it is 10 and if m is, of course the index will start from m plus 1, that is from 6 to 10. So from 6 to 10 there will be 5 elements, so its size should be, what its size should be, its size should be r minus m. Okay, so now what I'm going to write, I'm going to if we know the size of both arrays, now I'm going to create two arrays. Let's say array 1 of size 1 as well as array 2 of size 2. Okay, now I'm going to copy the elements of that array into my, the main array into my array 1 and array 2. So let's say this is a main array and I'm going to copy that element from L to M into my first array and from M plus 1 to R into my second array. So for that I'm going to create for int I is equal to 0, I is less than size 1, I plus plus, and array of 1 of I, let's say from array of 1 of I. So that, let's say here it is not 0, it is 2 to 5. So how I can go with that from let's say if I'm writing L plus I, then means in the first case I'll get 2, in the second I'll get index 3. So I can write array, main array, that is, it should be I is equal to 0 semicolon. Okay, so I'm saying I plus L. Okay, so I've copied the elements in that in the temporary, that is array plus, that is array 1. In the same manner I'm going to do it for array 2, and the I is equal to 0, I is less than I size 2. This time the size of array is size 2, and I'm writing array 2 into array 2. Let's say array 2 of I, I'm going to copy the element from the main array, that is going to start from m plus 1. Right now it is starting from m plus 1. I'm going to write I, that in the first case do not do, and in the second case please keep on increasing one by one. Okay, if we've copied the array, let's say 2 and 3 is in this array, 5 and 7, let's say 1 and 5 is in this array. So if we have copied this those elements into this array, so now what I'm going to do, I'm going to create run a while loop until any of these let's say from, for this array I'm going to write I'm going to create an iterator, let's say that is I, and for this I'm going to create let's say a pointer or iterator, that is j. Okay, so I'm going to compare that array 1 of I from array 2 of j. Okay, you are saying add a after 0, where we have written 0. Okay, Shay, I think we have already did that. Thank you. So so I'm writing for 2, I'm checking that, let's say I is right now pointing to this, I is having index of this and j is having index of this element. So I'm going to do until I is not less than the size of this, I should not be greater than the size of this array, and j should not be greater than the size of this array. So what I'm saying, if array of I is greater than the array of j, right now L and R, you're saying, okay, sorry, we have to write M. Okay, it should be left, it should be right, because I've done it using R and M, R and L. So I was writing L and R. L means left, R means right. Okay, either you can change it from here, either you can write it here. Okay, so here what I'm doing, I'm comparing the first two element, which one is the smaller, I'm going to update that element in the array, and again I'm going to increment which one, let's say this I've written one here, so I'm going to increment j by 1. So now my j is pointing to 5 and I is pointing to 1. Again, I'm going to compare it 2 with 5. Now 2 will be written here and I will be pointing to 3 now, and j will be of course greater than the size. So I'm not going to compare it again. So sorry, j will be still be pointing to 5. Sorry. So for I'm going to again compare 3 and 5. So 3 is smaller, so I'm going to write 3 here and I'm going to increment by 1. So this time the I will be greater than the size of this array. It means that we have already completed this array and we have left with this. What are the elements that we are left directly? Copy that elements at the last of that array. Okay. There will be two cases. Either we will be left with this array or we will be left with this array. There will be two cases only. So we cannot left with this both arrays. Okay. So what I'm going to write, let's say I'm going to int I is equal to 0, int j equal to, sorry, let's say j equal to 0, and k. For k, why I'm writing k, k will be pointing to, let's say k will have the index of in the main array. K will have the value in the main array, that what is the index up to where we have filled our array and up to where we have left. Okay. So k will start from L, sorry, that is left. Okay. So k will start from left. So now what I'm going to write, while my I is less than size 1 and j is less than size 2. Okay. If both I and j is less than its size, in that case compare if array of 1 of I, if it is less than array 2 of j. If it is less than, in that case what you need to do, in the main array, that is k equals to array of I. It means array of I is lesser than array of j, that is array 1 of I and array 2 of j. So what I'm going to update it, array 1 of I, I'm going to update it by array 1 of I. And because we have written or the element of array 1, that is at the index I, so I'm going to increment my I by 1, as well as because we have written in the main array, I'm going to increment my k by 1. Okay. If it is not the case, what you have to do in that, it means that array 2 will be lesser or it will be equal. In the equal case, you can write either array 1 or array 2. If it is array 1 is less than array 2, if it is not the case, it means either array 2 will be less or both will be equal. In that manner, what I'm going to write, array of k should be equal to array 2 of j. And in that case as well, in that case I'm going to increment my j now, not I. I'm going to increment my j as well as I'm going to increment my k, because in both conditions k will be incremented, because we have written something into my main array. So k will be here. Okay. So let's say if we have came out of this loop, it means either I is greater than the size 1, either j is greater than size 1. It means we have completed the first array or we have completed the second array. Okay. So in that case, what I'm going to do, I'm going either one will be the uh, in only one array will be there, that is left with that element. So I'm going to perform the while operation for both. Let's say if there is an element in the first array, if there is element in the first array, then I will be less than size 1. So in that case, what I'm going to do, I'm going to fill my main array with the array of I and I plus plus k plus plus. Okay. And if it is not the case, if I is not less than size 1, it means j will be less than size 2. Okay. So in that case as well, I'm going to write array of k equal to array 2 of j, and I'm going to increment my j here, j plus plus k plus plus. Okay, is it fine now? So this will be our merge function. So what I'm doing here, I'm just creating two temporary array and I'm comparing the values of those array, and I'm filling the main array again. Let's quickly run it. Let's see whether we are getting the, okay, we have to print it. Let's see whether, so array of I plus L, it is in 21 line. We have written array of I plus L. Okay, it should be left again, not the L. And here it is mid. Okay, fine. Let's see. Okay, we have not printed our array. Let's see. Let's print the, let's print it array and let's pass the size of that array. Let's see whether we are getting the correct output or not. Okay, we are getting in sorted array 2, 7, 9, 16, 17, 25, 42, 48, and 49. Means we are getting the correct output. Let's see. Let's add some more values to array. Let's say 100, 105, 6, 8, 9, 89, or 8, 95, 45. I should be getting a sorted array. Okay, we are getting an sorted array. I think so. 2, 6, 7, 8, 8, 9, 16, 17, 25, 42. We are getting a sorted array. So the question, the code is clear, or do I need to repeat it again? The merge sort using recursion. What we are doing, first we are dividing our given array, that is main array, into two sub arrays, and we are keep on dividing. Let's say this is an array. Let's do it for a smaller array. Let's say this is the array that is given, that has been given with us, and we have to sort this. Let's say there are 4 elements only. Let's quickly try run our code. Let's say 2 is here. Let's say the elements are not sorted. Let's say it is 7 is here. 8, 7, 8, 5, and 3. Okay, let's quickly try run our code. Let's see how we are getting this. How will we getting this 3, 5, 7, and 8? So let's say this here will be this array will be passed through it. Let's say 7, 8, 5, and 3, and starting position will be 0, and this in this size -1, it means the size of this array is 4, and it will be 3. So index 0 and 3 will be passed through it. Let's say it is 0, it is 3. Index 3 is being passed. Now what I'm saying, in my merge sort function, I'm checking whether left is greater than right. Left is 0 and right is 3. Left is less than 3. Yes, it is 3. So what I'm doing, I'm just calculating the middle element. So 0 plus 3, that is 3. 3 divided by 2, and we are taking the integer part, so it will be 1. Okay, it means that m is this, it is 1. Okay, and I'm saying merge sort again, left array, pass the complete array. Now the left should be 0 and the right should be, because if we pass this array again, in the left will get the left and the right will get the m. So I'm right now I'm saying I'm passing this complete array again, but now I'm saying in the second case, now what I'm saying, that 7 and 8 is here, and what I'm saying, that first I'm going to complete the task for this call, then I'm going to get into this. Okay, so how our computer is doing for 7 and 8 right now, this is L and this is M, this is R, sorry, this is R. So for left and right I'm writing L and R, and 5 and 3 will be same in that manner. Okay, so it is again going to say that left is less than right. Yes, left is less than right because left is 0 and right is 1. So I'm going to get the middle element again. Let's say now left plus right divided by 2, 0 plus 1 divided by 2, that is 0. Now our middle is this element. Okay, so what I'm going to call that this left, this is this function again for this element, because we have already divided this. Okay, so this time the left is 0 and the right is, that is mid, that is also 0. So again it is going to come for this function, that left is less than right. No, it is not less than right. So it is going to revert it. It is going to revert here. Okay, because it is not going to do anything. So it will come to this point. So a because here what we are saying, that mid plus 1 and right, because here mid was 0 and mid plus 1, that is 1 and right is also 1. So again it is going to call for 8. It is not going to do anything, it is going to just return from here. So left and right is here and the middle element is this. So left and right both we have completed its task. Then it is going to merge it first it is going to merge it 7 and 8. So it is going to call a function that is merge, and we are passing our complete array, and we are saying that left comma right comma mid, that left is 0, right is 1 and middle is 0. So come to our merge function again. What merge is doing, that m is right now 0 minus left, that is 0, 0 minus 0 0 plus 1, that is 1. So it is creating an it is in size 1 it will store 1. In size 2 what I'm saying, that right minus m, 1 minus 0, that is 1. So size 1 is also 1, size 2 is also 1. So it is going to create the two arrays of size 1 and size 2, both will have the size 1. So what I'm doing in that array, in the first array, what I'm writing in the first array, I'm writing 7. In the second array I'm writing 8. Okay, we've written this, we have copied this element of these arrays, and now what I'm saying, that create I, j and k. Right now I is 0, j is 0. Okay, fine. K is equal to left is also 0 now, so k is equal to left. So I'm saying I is less than size 1. Yes, j is less than size 2. Yes, because size 1 and size 2 is 1 1, and I and j is 0, both are less than its size. So what I'm going to do, if array of 1, this is array of 1 of I, let's say that is 7, is less than 8. No, the 7 is not less than 8, so it is not going to do anything. Else what it is going to do, array of k is equal to, sorry, yes, 7 is less than 8, sorry, 7 is less than 8. So what it is going to do, array of k is equal to array of I. It means in the main array k, right now k is pointing to 0. So in the main array I'm going to write 7, because it is 7 already written. So it is going to update it by 7 again, so it will not make any difference. So 7 will be written here again. Else condition will not be true. So I plus plus, I is now 1, and k plus plus, that is k is also 1. So again 1 is less than 1. No, so it is not going to check for this condition. So this while loop will be broken. J is still pointing to this element, and k is pointing to this first index. So I'm writing I is less than size 1. No, I is not less than size 1. I is already 1. 1 is not less than size 1. Here I'm writing j is still 0, and j is less than size 2. Yes, it is less than size 2. So what I'm writing here, array of k, that is 1, array of 1 will be array 2 of 0. Array 2 of 0 is 8, so I'm going to write 8 here again. So it is already 8 written, so I'm not going to do anything. Okay, so this function has completed its task. So 7 and 8 has already been sorted, because this function call was for this function, that is left, and again it is going to call it for the right. And now it is saying that m plus 1 should be come into left. M is here, m was 1, and now m is m plus 1, that is 2. Now it is 2, it will call 2 to 3. So in the array, now left will, in the left will get 2, in the right will get 3. So again now we have to sort this function. Now we have to sort this array. Now left is this and right is this, and we have to calculate left plus right. We have to calculate the mid, left plus right, that is, let's say 2 plus 3, 5 divided by 2, that is 2 again. So it will come, the mid will come here. So if we call our function, so if it is one element, it is going to return, it is not going to do anything. If it is second element, it's not going to do anything because it's only one element. Okay, so if my left is this and right is this and mid is this, now I'm going to call the merge for this call, particular this call, not this call. Okay, for this call again I'm going to merge it, so it will return. And how it is going to return this merge function? Merge function will sort this because 3 is lesser than 5, so 3 will come here. Let's say 3 is going to come here, and again it is going to create a size of 1 and 1 array. So 3 comes here, 5 comes here. So uh, the right call is completed. So this is 7 and 8, this is 3 and 5. Then it is going to call merge for this function again. Let me resolve this. Let's see now how it is going to perform. So now here I are 0, left was 0 and right was 3 and mid is 8 currently. Okay, so it's left and right has completed, so it should be 3 and 5 because we have already merged the right part of the array. We have already sorted the right part of the array, so it will be 3 and 5. Left part is sorted, right part is sorted, again it is going to merge it. So 7 and 8, in that case what it is going to create, it is going to create the size of uh, two arrays, size of 2 and 2, because again if we calculate the size, m is currently 1 minus 0, that is 1 minus 0 1 plus 1, that is 2, size 1 is 2, and 3 minus m, right, minus m, 3 minus m is 1, 3 minus 1, that is 2. So it is going to create two arrays of size 2 and 2, and it is going to merge them accordingly. So 7 and 3 will be compared, so 3 will come first. So I is still pointing to 7, j is pointing to 5, so 7 and 5 will be compared, so it will come to 5. So we have j will reach to greater than size 2, so it will not do anything. So again it will come to this while loop, still I is less than size 1. Yes, so what I'm going to write, I'm just going to update my main array with the first array, the data of first array, it is 7 and 8. If it comes here, j is already greater than size 2, we are not going to do anything. So 3 5 7 8, we have completed the task for this call, and we are going to return it because we have its return type is void. We don't need to return anything, so it is going to return because array is passed by reference, so it is going to, the changes is going to be shown here in this main function. If I'm printing, I'll be get 3 5 7 8. Okay, as the merge sort function is clear, or do anybody is having any doubt? Okay, Aryan, thank you. So as we have seen that recursion has helped us a lot, that doing merge sort, because if we have not implemented, we would have not implemented our recursion, we would have done some iteration, so it will have a more complex, we would have created a more complex code. Okay,